this video, we will be talking about protein synthesis. Before we begin, let's remind ourselves that translation turns mRNA into a polypeptide, which is a chain of amino acids. Protein synthesis, aka translation, is divided into three stages: initiation, elongation, and termination. So I want you to keep this in mind as we're talking, because this is the overview. Now, before we begin, we need some background information about prokaryotic and eukaryotic ribosomes. Eukaryotes have a 40S and a 60S subunit, which eventually make up the 80S ribosome. The S represents sedimentation coefficients. Prokaryotes have a 30S and a 50S subunit, which eventually makes up the 70S subunit. So our ribosomes are different than prokaryotic ribosomes. This is great for antibiotics, which I'll talk about at the end. If you have trouble remembering this, I like to remember this as eukaryotic ribosomes are even and prokaryotic ribosomes are odd. They each also go up by 20 from small to big to the total ribosome. This will be important later on in this session. Now, let's first start off by talking about initiation, which is the first step of protein synthesis. So, let's take a look over here. For protein synthesis to begin, we need a ribosome, as well as an mRNA that has directions to build the protein, as well as an initiator tRNA that carries the first amino acid in the protein, which is usually a methionine. After all of these come together, they form the initiation complex. So as you can see over here, you have the ribosome subunits, you have the mRNA and the tRNA, and all of those come together to form an initiation complex. First, the tRNA carrying methionine attaches to the small ribosomal subunit. Together, they will bind to the 5' end of mRNA by recognizing the 5' GTP cap. Then they walk along the mRNA, so they go towards the 3' end, stopping when they reach the first start codon, which is AUG, as you can see right here. If you're not sure about what the 5' cap is, we have a detailed video on mRNA that I will link here. Before moving on to the second stage of protein synthesis, we should talk a little bit about the ribosome structure. So let's take a look over here. The ribosome has three sites: an A site right here, a P site, and an E site. The A site is the site for incoming amino acyl tRNA. The P site is where the growing peptide is located, and the E site is where the empty tRNA exits, as you can see right there. So now, let's talk a little bit more about the second stage of translation, which is elongation. So elongation also has certain steps to it. As a reminder, amino acyl tRNA is just a tRNA that is bound to its respective amino acid. So, the first part of elongation involves the amino acyl tRNA binding to the A site. The exception is that when you have the initiator methionine over here, that binds to the P site, but everything else binds to the A site. This step requires an elongation factor as well as GTP. So after the amino acyl tRNA binds, our RNA helps catalyze the peptide bond formation, which transfers growing polypeptides to the amino acid in the A site. The ribosome will then advance 3 nucleotides towards the 3' end of the mRNA, and it will move the peptidyl tRNA to the P site. And then one tRNA will go to the E site to exit, and a new one can enter at the A site. If you are getting confused about which site is which, I remember it as APE. And remember that A is arrival, and E is exit, and P is in the middle. Also, remember that when the protein is made, the protein synthesis occurs from the N terminus to the C terminus. So as you can see here, the N terminus of a protein and the C terminus of a protein. The N terminus is also called the amino terminus, NH2 terminus, N-terminal, or amine terminus, and that's the start of the protein or polypeptide. The C terminus is the end of the amino acid chain, terminated by a free carboxyl group over here, a COOH group. So that is elongation. The last stage is termination. In this step, eukaryotic release factors will recognize the stop codon. So as you can see, this is a release factor. It will recognize the stop codon and release the polypeptide from the ribosome. Release factors fit into the P site, even though they're not technically tRNA. They add a water molecule, which hydrolyzes and breaks the last amino acid off. This step requires GTP as well. If you need to remember the stop codons, I like to remember it as you are annoying, you go away, and you are gone. So UAA, UGA, and UAG. Now, let's quickly talk about how we can use the fact that our ribosomes are different than prokaryotic ribosomes. We use this when we use antibiotics. For example, certain antibiotics, such as tetracyclines, erythromycin, clindamycin, and aminoglycosides, mess with either the 30S or 50S ribosome subunit, and this causes issues with protein synthesis for the bacteria, but not for us, because we don't have 30S or 50S ribosomes. We have 40S and 60S subunits. Now let's sum up the important facts of this video. Translation consists of 3 stages: initiation, elongation, and termination. Initiation occurs with the help of the 5' methyl cap of the mRNA, as well as initiation factors. Elongation is when the polypeptide forms, and this step will use GTP. Termination is carried out by release factors when certain codons are encountered. Thank you for watching this video, and if you got this far, please give this video a like. Comment below with questions or if you want us to make a video on a different topic. Lastly, don't forget to subscribe so you don't miss a future video.